Hello, class. I want to lecture on logic today. It's a good subject because so many conclusions are drawn and they are not logical, so we need to learn a little logic. First of all, if you have a statement P, a proposition, there are only two cases. Either the statement is true or false. If you have not P, the negation of P, then if the statement is true, the negation of the statement would be false. If the statement is originally false and you negate it, then the statement is true. So we can illustrate this using what we call a truth table. The truth table at the top of the page, and I'm not sure you can view it, but I'm testing the system, would have two rows, a true row and a false row for P. And the negation table, not P, would have the opposite entries in it. Sometimes we consider two propositions at a time, P and Q. There are four cases when you consider two statements. Both could be true. The first one, P, could be true, the second one, false. Or it could be that the first one, P, would be false and the Q would be true. And finally, both could be false. When you look at those four cases and you think about what we call the disjunction or the or statement, it would be P or Q, and you would look at the entries for P and Q and decide on the truth of an or statement. Well, an or statement is true if any part of it is true. So if P is true and also in the entry for Q, it's also true, and you have an or statement, P or Q, then P or Q would be true. In the case TF, the or statement would be true. In the case FT, the or statement would be true. But if it's F, false for both, then the or statement would be false. You have the conjunction. Conjunction works like intersection. The conjunction statement is true when both parts of the statement are true, the P part and the Q part. So if you have your truth table with four entries, TT would give us true for and. TF would give us false, FT would give us false, and FF would give us false. So the and statement is true when both propositions are true. The or statement functions like the union in set theory. The union of two sets is anything in the first set or the second set or in both. The and statement in logic is similar to the intersection of two sets. When you have the intersection of two sets, you shade what is common to both sets. We normally do it using circles, simple closed curves. We let the circles overlap, and we shade the area of intersection for the and statement. The and statement in logic is very similar to the and statement of the conjunction in set theory. Now, I want you to read your textbook carefully and take notes. And if you need to, look at the video more than once and take notes. We can build truth tables. I'll give you an example. If we have P or not Q, we first make a column for P with four entries, T, T, F, F. We make a column for Q, TF, TF. We can build the or statement and have the entries TTF, no, TTTF. But if I ask you to fill out the entries for P or not Q, you need an extra column for not Q. The entries would be opposite to what is in Q, and you would have FT, FT. Then you would link with R the P column with the Q column. Therefore, the entry for a P or not Q statement would be TTFT. Now, if I've made a mistake, you correct me. But this is your first simple video on the fundamentals of logic. Thank you.